Welcome to Classic 8.4 Part 3. We're going to talk about a couple of identities and I'll send you guys off to do some classwork. So first, everyone highlight right over here, changing to sines and cosines. That's going to be strategy number 1. That's a good idea in general whenever you're working with pretty much any identity. So here, let's pick the left side, like that. And let's just change it all in terms of sine and cosine. So secant is 1 over cosine. Cotan is cosine over sine. Take a look and notice how the cosines will cancel out. We are left with 1 over sine, which is cosecant, which is exactly what we wanted. Let's put our happy face. Let's move on. Let's go to example 3 here. So again, let's highlight our technique using factoring. So this will be strategy number 2. Clearly pick the left side. The right side, it is kind of complex, but it'd be pretty hard to break down, cosine cubed. So obviously we're going to factor this. So factor out cosine x. You have 1 minus sine squared x. Don't forget your equal sign here. And hopefully from last class you recall something. Everyone highlight this right here. 1 minus sine squared. We know what that is. That would be cosine squared x. And now we have cosine cubed x. Let's put a box. Happy face. Good. Okay, let's go to example 4. Okay, using 2 techniques. So I'm going to model this. We talked about it already in class, but let's pick the left side first. This is going to be called fraction splitting. We've done this quite a bit already. So again, this is fraction splitting. You just separate the fraction. So 1 over cosine theta plus sine over cosine theta. Now we have secant theta plus tan theta. You box that, and there you go. Notice how easy that was. So for your notes, you want to make a note that fraction splitting is this idea that if you have a plus b over c, that is simply a over c plus b over c. What you never do, so I'll put never do, is this. A over b plus c. You can never split a denominator, so this will never be the case. This is just nonsense, so make sure you guys cross that out. Never want to do that. Okay, the second technique. This is simply common denominator. So if I'm going to pick the right side, so I'll do this in blue. Let's say you want to pick the right side. Secant is 1 over cosine. Tangent is sine over cosine. You have a common denominator, so add them. 1 plus sine all over cosine. So look how easy that was. So again, let's box that. And now we are good. And again, don't forget your happy faces. Let's put those down. Okay, here we have a much more complex example. So we're going to have to use a bunch of techniques here. So first, let's pick the left side. I'll put a separator for you. We're going to need a common denominator, so let's just multiply this left side by cosine over cosine. So we get cosine squared x over cosine x times 1 plus sine x. Plus, and notice how the right side, this is going to need a 1 plus sine x to both sides. So 1 plus sine x there, 1 plus sine x on the bottom. So we'll just write this 1 plus sine x squared all over cosine x, 1 plus sine x. What's important here is you leave the bottom factored. You don't want to multiply that because we're expecting stuff to cancel. So you don't really want to multiply. You could, but again, it'd be a waste of time. Now let's combine it. Notice how your denominators are now the same. So we have cosine squared x Hopefully you guys can FOIL that in your head. That's 1 plus 2 sine x plus sine squared x. This is all over your common denominator, which is cosine x, 1 plus sine x. Now take a moment and look at this, and hopefully you notice something. Let's everybody highlight this cosine squared and this sine squared. Take a moment and think, well, what is that? What's cosine squared plus sine squared? Hopefully you remember these things become the number 1. So now we have 1 plus 1, which is 2, plus 2 sine x, all over cosine x, 1 plus sine x. And look at the top there, we have a common factor, so let's just factor that right now. 2, 1 plus sine x, and take a look at that. We cross those out. 2 over cosine x is, in fact, 2 secant x. So there you have a much more complicated example. Make a fancy box there. Okay, 2 more examples. Okay, so this one is going to be a special technique. Notice how the left and the right, they're both pretty weird. So really you could pick either side. I'll pick the left side. And just to show you, I'm just going to rewrite it. First, notice you can't split the fraction here. You have a 1 plus cosine on the denominator, so there's nothing really you can really do. So what we're going to do is a technique called multiplying the conjugate. So again, that's called the conjugate. So hopefully you recall from Algebra 2A class that the conjugate of A plus B is simply A minus B. So notice how the sign is just going to switch. So we're going to multiply this thing by 1 minus cosine over 1 minus cosine. Now the top, again, leave that factored because we're hoping something will cancel. And the bottom, you want to multiply this. This is the whole point of it, because if you multiply it, you create a difference of 2 squares, and you have 1 minus cosine squared. So again, think about last class. Highlight this thing, and think about, well, what is that? 1 minus cosine squared is, as you should remember, sine squared. So write that, sine squared. You have sine x on the top, 1 minus cosine x here. You cross that out, and take a look at that. 1 minus cosine x over sine x, which is the exact thing we wanted. You could also pick the right side to practice and do the exact same technique. So again, that's called using the conjugate. And for thinking about when to do this, there are a couple conditions you want. So on our notes, let's put conditions for using the conjugate. This is not like the hard rules, but this works, I would say, maybe like 90% of the time. Condition 1 is you want a fraction to equal a fraction. So notice on our problem that is true. We have 2 fractions equaling. The second condition is you want to notice a 1 plus or minus cosine or 1 plus or minus sine. If both of these conditions are fulfilled, it's likely you're going to need the conjugate. So I'm going to want you guys to box that. So let's box this. And in fact, let's make that a 3D box. Just like that. And shade that in, because this is a very helpful technique, but it's a special technique because you won't use it all the time. And now let's go to the last example. I'll put a line here for us. So clearly we are going to pick the left side. A lot more stuff to work with here. Equals, so tangent, let's change that to sine and cosine. That's sine over cosine. And then let's take a look at this next part. We see a negative in there. Let's take that out. Remember, sine is odd, so that's plus sine x. And now we have 1 plus cosine x. Okay, so a lot of people think you try the conjugate here, which you could, but this isn't quite the condition we want. We do have the 1 plus cosine on the bottom, and tangent technically is a fraction, but the end result is not a fraction, so that's why we don't want to use the conjugate here. Instead, let's just clear the complex fraction, meaning you don't want a fraction in a fraction, and then let's see what we have from there. So to do that, let's multiply by the common denominator, which would be cosine over cosine. Let's drop our equal sign. So be careful when you do this, make sure you distribute to everything. So the top is going to be sine, the cosine should cancel there, plus cosine times sine. And the bottom is going to be cosine 1 plus cosine. Again, you could multiply that, but don't. You're expecting it to cancel, so leave that factored. Now on the top, notice how you have a sine and a sine. So let's factor that out. Sine x, 1 plus cosine x. And then cosine x, 1 plus cosine x. Notice how these cancel. Sine over cosine is in fact tan. So let's put a box, happy face, and there it is. Okay, so that was everything. So make sure you save this video link. It'll be an email. I'll leave it on YouTube, and then now we'll take questions in class, and we'll do some classwork.